Assalaamu calaykum waraxmatullaahi wabarakaatuh. Magacaygu waa injineer Khadar Axmed Faarax. Halkan maanta waxaan idinkula wadaagayaa course ku saabsan course physics ah oo lagu qaato dhammaan jaamacadaha adduunka. Course-ka magaciisa waxaa la dhahaa Physics 2. Marka u diyaar garooba. Physics 2 waxa weeyaan waa course ku saabsan electricity-ga iyo magnetism-ka. Marka qaybta hore waxaan kaga hadli doonaa magnetism. Electricity baynu qaybta hore kaga hadli doonaa. Electricity-gu sidaynu ognahayba waxa weeyaan waxa lagu af Soomaali ahaan waa qulqulka danabka, kaas oo mataqaanaayey saameyntiisu adduunka oo dhan laga dareemo. Markaaba waxaynu isku dayeynaa inaynu wax ka ogaano sida uu u dhasho electricity-gu iyo terminology-ga kala duwan ee loo isticmaalo electricity-ga. Markaa si aynu electricity-ga aynu wax uga ogaano, waxaanu dib ugu noqonaynaa phenomena la yidhaha electrostatic phenomena. Electricity marka la leeyahay waa sidaa idin sheegay waa qulqul waa socda, laakiin electrostatic micnaheedu waxa weeyaan wixii uu taagan yahay. Mar hadduu wixii taagan yahay, marka wuxuu u baahan yahay wax dhaqaajiya si uu u noqdo electricity. Marka horta waxaynu ka bilaabaynaa electrostatic danabkaa taagan sida uu mataqaanaayey ugu dhasho walxaha kala duwan. Waxaa muddo laga joogo qarniyo aad u fara badan saynisyahan reer Greega uu mataqaanaayey walax la yidhaha amber ayuu wuxuu ku xoqay walax silkiya. Marka amberku wuxuu noqday magnet. Waxbuu walxaha yaryar uu soo jiidanay, macnaha wuu charge garoobay. Amberkii waa charge garoobay markii lagu xoqay warax xariir ah. Marka waxa weeyaan waxyaabaha yaryar warqadaha iyo xashiishka waxaas soo jiidanayaa because force ayaa ku dhashay ama electromagnetic force. Marka waxaa ku dhalinayaa mataqaanaa force-kaas waxa weeyaan waxaa la yidhaahdo charge. Walaxdaas way danabaysantahay haddaad maqasho waa charging. Tusaale ahaan haddaad albaabka qabsato, albaabka gurigiina oo bira, waxaa laga yaabaa in aad dareento inay wax kugu dhageen oo kale. Electricity maaha, laakiin walaxdaas waa charging. Marka waa electrostatic. Danab taagan baa jira, danab taagan. Waxa weeyaan danabka siyaabo badan oo kala duwan baa lagu dhalin karaa. Waxaa lagu dhalin karaa iyadoo xoqitaankaas oo kale by friction sida aynu sheegaynay oo kale ah. Waxa kale oo lagu dhalin karaa by contact inaynu mataqaanaayey walax danabaysan walax kale oo neutral ah aynu saarno. Marka by contact-na waxa weeyaan danabkii wuxuu ka gudbayaa walaxdii charge garaysnayd oo wuxuu tegayaa walaxdii aan charge garaysnayn. Marka waxa weeyaan waxaan soconaya waa electrons. Protons waxa weeyaan iyagu waa static. Protonsku nuclear-kay ku jiraan. Number of protons-ka iyo number of neutrons in the nucleus waa isku mid. Marka waxa weeyaan neutrons-ku iyagu waa neutrons waa charge ma laha, waa neutral. Protonsku waxay leeyihiin positive charge, electronsku waxay negative charge. Marka labadaas ayuu ka dhaxeeyaa. Fusjiidadu waa waxa atomka ugu wacan in mataqaanaayey uu shape-kiisu soo ahaado. Okay, marka introduction ahaan horta waxa weeyaan electricity-ga oo ah arrinkaa dee adduunka wax badan ka bedelay. Waxay sheekadu kasoo bilaabmaysaa electrostatic-na waxay kasoo bilaabmaysaa sheekadiisu isna charge-kiisna wuxuu noqonayaa positive iyo negative. Marka today's course waxaynu doonaynaa inaynu ku barano the properties of charge-ka iyo property-da uu leeyahay, iyo sidoo kale waxaanu kalenu ku baran doonaa Coulomb's law waxa la yidhaha oo ah in aan mataqaanaaye aynu quantify garayno chargekii ama electric charge force between 2 point charges inaynu number ahaan ku sheegi karno iyadna la yidhaha Coulomb's law. Okay, markaa guud ahaan contentku sida aan idin sheegay waxa weeyaan waa sidaa. maanta lecturekana waxaynu ugu talagalnay in labadaa aynu baranno. markaynu labadaa aynu baranno kadib ayaa waxaynu u gudbi doonaa wixii intaa ka dambeeya oo noqon doona hadday noqoto electric field, hadday noqoto dipoles, hadday noqoto dielectrics, magnetism, so on and so forth. Okay, let's start. aynu markaa iska bilaabano. marka properties of charge waxa ugu horeysa like charges attract, repel, unlike charges attract. chargeska isku midkii way isdiidaan, positive to positive repels, but negative to positive attracts. way isa soo jiidanayaan. What does that mean? It's a property of charge. We don't know why. Okay, waxa weeyaan propertyga labaad waxa weeyaan propertyga charge can be quantized. in chargeka mataqaanaaye laga dhigi karo quantity, which means waxa weeyaan isolated charge can be expressed in terms of integral multiple of electron. Then charge of electron is 1.6 times 10 to the power of minus 19. So any other charge haddii aynu doonayno inaynu magnitudekiisa aynu cabirno waxa uu noqonayaa n times e, where e stands for 1.6 times 10 to the power of minus 19. marka q is equal to e. This means called quantization of charge. marka propertyga uu leeyahay charge waxa weeyaan can be quantized, yeah, which means any physically existing charge is an integral multiple of elementary charge, which is 1.9 times 10 to the power of minus 19. The third property is charge cannot be affected by motion. It cannot be affected by motion. macnaha haddii ay socoto iyo haddii kaleba charge waa same. The another property is charged body attracts to uncharged bodies due to electrostatic induction. yani haddii walax danabaysan tahay way soo jiidataa walax aan danabaysnayn. marka waa propertyga afraad. taasina propertyga shanaad waxa weeyaan electric charge is additive. yani waa wax laysku geyn karo. For instance, a force exerted by Q1 and Q2 and Q3 can be added like F1 plus F2, so on and so forth. We will see that in the when we are analyzing the problems. Okay, the total charge is the algebraic sum of the charges located at different points in the body. Okay, waxa weeyaan electric charge waa additive. Simply waxa weeyaan superposition principle baa la yidhaha. waa wax la isku geyn karo macnaha. Q is equal to summation of Q. Alright, charge, the most important property is that charge is conserved. Wow. Principle of conservation of charge applies here. Charge can neither be created nor destroyed. It's simply being transferred from one body to another. You understand? So what did we say? We said that properties of charge are 7. Like charges repel, Unlike charges attract, charged body attracts uncharged body. Charge on body remains unaffected by motion. Electric charge is additive. Charge is conserved, and charge is quantized. These are the 7 properties of electric charge. Conservation of charge. Conservation of charge. What does that mean? Conservation of charge. Charge can be neither created nor destroyed. We know that. It's called principle of conservation of charge. Quantization of charge means simply it's Q is equal to N E. Okay, how can we prove that? The next point is how can we prove that charge is quantizable or is quantized? We can confirm this by Milky Man's oil drop experiment, which contains two plates positively charged and negatively charged, and a point or a drop of oil is put inside of them. Then an electric force applies when you start the switch and you apply the voltage. That means an electric charge, an electric force is exerted on the drop of oil. There are two forces that are equal which apply on that drop. The first is magnetic force, which is mg, and the other is n. I mean, the other is. The other is the electric force, which is E times Q, and E stands for can be defined in terms of the voltage, which is V divided by D. So we can say that uh, charge is directly proportional to or inversely proportional to the applied voltage, which means QV is constant. Various potentials applied to balance, then the corresponding voltages are V1, V2, hence it's constant. It's constant. This constant means the multiple is the multiple constant. It's always constant. Constant doesn't mean that it's equal. It means that if one gives you two, then if you increase to two, two will give you four. And four is a multiple of two. So likewise, charge is a multiple of the elementary charge, which is 1.6 times 10 to the power of minus 19. So this guy has confirmed that charge is actually charge is quantized. We can do this exercise or example. For instance, you are given the charge, then you're asked about the electrons transferred. The equation that we will use is simply Q is equal to NE, and you can find uh, that. Okay, this also gives you different charges, which means that what's the point what's the conclusion of these results? These results will lead us to that charge is quantized, which means that 1.6, 4.8, and 9.6 are multiples of 1.6. If you multiply 4 by 1.6, it will give you 4.8. The same if you apply by 6. So this is just so this is for you. This is self-assessment question. So if you were asked that how electron transfer takes place, you are given a polythene piece found to have positive charge. So it has positive charge. It means electrons have been transferred from it to the wall, and there is a mass of transfer because the electron itself has has mass, isn't it? So mass is transferred. Uh, Hanging in equilibrium, two charges. This is relate you to the other equation that charge is inversely proportional to the voltage, which means that Q is equal to mgd divided by V. So you have mass, you have distance, you have gravitation. You can find the magnitude and the nature of charge on the drop. The nature is negative, I guess. Okay, finally we will go to Coulomb's law. Coulomb's law states that force is directly proportional to the product of the charges and force between two point charges, either attracting or repelling, is directly proportional to the product of two charges and inversely proportional to the square of the distance. The square of the distance. So this is helpful in finding the force uh, on two particles. The condition is for validity. It's only valid if the distance between the two-point charge is greater than the distance, the nuclear distance. Okay, and its importance is that uh, the heavy nuclei would not have been radioactive if there is no force. There's no force actually. So if we compare gravitational and Coulomb's force, there are similarities and differences. Differences that one is only attractive, the other is either attractive or repulsive. The second difference that in terms of magnitude, uh, one force is bigger than the other. Coulomb's force is much larger, or is much stronger than the other. Finally, we will go to example. Uh, Other example is okay. Uh, Self-assessment where theoretical metallic spheres have an equal opposite charges placed to bring into contact where again placed now first brushes one with to calculate the final charge on them. Two-point charges Q are fixed at a distance where third part should be placed in line joining so that condition will be should be stable and which unstable. Calculate the absolute permittivity of water if the electric resistance is 8 to 1. So in summary, we have done that. And let us discuss about the answers of the self-assessment questions. Self-assessment questions. You can read it. Can read it. Read it. So that's the end of our lecture.